eccentric node. We use the node divided by the area. And for strap footing means the length divided by the width more than 10 strap footing. And we use the node per unit weight, unit length divided by the weight. Okay. But for the vertical eccentric node, the location of the vertical point node not at center, like this, maybe eccentric node. For vertical eccentric node, we use this equation. This equation may be complicated. Okay, here the ms my means moment. Moment to the x axial or y axial. Okay, and I x I y means inertia, yeah, inertia of x axial or y axial inertia. And for strap footing, we use this equation. Here's only one direction eccentric. So we use this equation. Here we discuss some cases for the centric or eccentric node. For rectangular footing, maybe rectangular footing is widely used in foundation engineering. So for the rectangular footing, we determine the contact pressure. Okay, here distribution may be uniform. For the centric node. But for eccentric nodes, the node point here and have the offsetting EX and EY. We need offsetting. Offsetting. Okay. And the moment x equal the P times EY and the My equal P EX, okay, and the pressure at the edge edge of the foundation. We can use y equals the half of the width, half of b, okay? Y half of l, x half of b, and result for one direction, for one direction offset, maybe ex equal e and ey equal 0. Here we can choose this equation. Maybe the maximum values and the median value at the two edges. Here the median value, here the maximum value. Okay. And for 14, notice at center in only one direction. The distribution may uniform or triangular or triangle due to the offsetting. Okay, here the offsetting is equal or more than width divided by 6. The distribution will be triangle E less than width divided by 6, and if the offset equal width divided by 6, if the distribution of triangle. In this case, the middle equals 0. Okay, and another case for offset more than weight divided by 6. In this case, with the middle value is negative values, okay, means some tensile stress appear in the calculated stress, okay. In some region, tension appears between the foundation and the ground and the subsoil. But we know the soils have no tension stress, okay, stress. So maybe in this region, the foundation and the ground may be separate. So the stress will equal 0 in this region. So the distribution should adjust to a triangle. But in this case, case, the distribution not same with this case due to some region the stress equal 0. So we adjust the result and use the equivalent of stated. They can determine the K and the maximum values for adjusting distribution. Okay, here K equals B divided by 2, half of B minus offsetting. Okay, use the equation of the vertical direction. Okay, maybe the triangle, the center of triangle here, same with the location of the node. That's right. Maybe the center of the triangle, same with the node point, location of node. Okay, so K equals half of B minus E, and then not B effective weight of triangle, maybe 3K. Okay, so the P, the total force P equal the area of the triangle. Okay. Yes. Okay. So the maximum value but here have times out length of foundation. So okay. And then exercise. A strap has a base weight of B. The action of the resultant of vertical force is equivalent to a vertical point node and the moment of the base at center point that base vertical point node and moment. The vertical component of the resultant force is 20 hundredths, 2,000 kN, while the moment 1,500 kN. Okay. What may contact the action is distributed in triangle pattern. Here, the foundation is a vertical eccentric subjected to a vertical centric node or vertical eccentric node. Here have the vertical point node and a moment. So maybe an eccentric node. Yes, eccentric node subjected to the foundation. And the distribution maybe triangle or trapezoid due to the offsetting. Is that right? Maybe the offsetting less or equal b divided by 6. The contact reaction distributed in triangle pattern. Okay. For offsetting equal b divided by 6, maybe a triangle. Here the medium pressure equal 0. But for lasting offset lasting weight divided by 6, some region appears tension, okay? But for source, no tension. So in this region, the pressures may be equal 0. So the distribution is also a triangle, but have a short wave compared with the equal. Okay. So how to calculate the offsetting? The offsetting equal moment divided by the vertical node. Okay. So the offsetting equal 0.75. Okay. And what may contact reaction distribute in a triangle pattern may be more than or equal 6 E, right? So here's 5.0 4.5 meter. If the weight of the footing equal 4.5 meter or more than 4.5 meter, maybe the contact pressure distributed in a channel pattern. Okay. Okay, next we'll continue to the stress induced by concentrated vertical load. Concentrated vertical load maybe not very